Okay, Bismillahirrahmanirrahim. Okay, we start our first chapter for formal method. Basically, this one is just an overview of formal method. Later we see later we see what is the main definition of formal method. Okay, the advantage and disadvantages of formal method. Basically, formal method. Uh, Okay, formal method is about how you want to measure a rigorous process in a software development method to build the software and also for the hardware lah. Okay, formal method basically uses a mathematical proof as a complement to system testing in order to ensure the correct behavior. The main point here to ensure the correct behavior. Okay, to ensure the correct behavior. Behavior of the system. Okay, and then we are looking also for some formal method supporting tools. Okay, and then in computer science, specifically software engineering and hardware engineering, formal methods are particular kind of mathematical rigorous process or technique for specification, development, and verification of software and hardware system. Okay, formal method also are system design technique that use rigorous modeling, rigorous modeling uh, in other in order to design the system. Yeah. Okay, for the formal method, model is approach to software engineering that uses specific characteristic that we learn later on. Okay. Okay, this one is just an overview of formal methods. Is specification verification for software and hardware. We are using semantic and abstraction modeling. Okay, the main problem for the semantic is delay. Semantic because you need to do a lot of equation, and then just I said before, we need to have the characteristic of the system. Okay? The main characteristic of the system. Okay, and then formal method adopt a three-step approach to modeling and evaluating the system. Okay. First one is using mathematical syntax and semantic to eliminate the imprecision and ambiguity. Yeah, especially you need to write down the coding and then a specification. Basically, it is not a plain English. Yeah, which means that you need to play around with the abstraction. Okay, from the abstraction. On the specification, the engineer will develop a set of theorem, and then from the semantic, build a set of theorem about the behavior of the system. These theorems are verified through the mathematical proof, and then to ensure that the system behavior is logically consistent, uh, and then after that, this one will allow the designer and engineer to discover some error or flaws. Okay, and then it prevent costly error from the emerging in the later stages of development. Okay, for the notation we have ASM, automotive simulation modeling. We have actor model, and then we have P method and so on. This one is just for the notation. And then some of you might ask why we are using formal methods. We are using formal method because of we want to define the system and articulate the implicit assumption to write a specification for the uh, coding of the system, especially when we want to prove the program either the program is true or false. Okay, so far do you have any question? Ada soalan ke setakat ni? Okey ke? Boleh ke? Okay, nowadays formal method are being used in cyber security lah. This one is formal method. Okay, why formal method required? This one is a very common problem. Some of you might ask why formal method required. As I said before, formal method required because of three main stages. First one, we want to systemize and introduce a rigorous process into all phases of software development phase. And then formal method is we want to have the mathematical proof in order to complement to system testing. This one is to predict correct behavior of the system. Boleh baca ke? Boleh baca ke? Boleh kan? Boleh. Okay, what is formal method? I have explained to you. Formal method can be foundation for designing a safety critical system. What is safety critical system? Safety critical system is the system that critical to life. For example, if we see here, we have aerospace. Why aerospace is very critical? Why? Kenapa aerospace ni dia critical? Why aerospace? We name it as a safety critical system. Kenapa? Ada siapa tahu kan? Okay, it is named as a life critical system because of any failures or malfunction, failure or malfunction, result injury or death lah. Other than aerospace, we can see automotive cars like Tesla brand. If you see the autonomous driving experience, especially when you drive the car without the intervention of the driver, this one is very critical, safety critical system, because if the system didn't measure or didn't take care of traffic, the driver might be in a serious injury or sometimes can be death. Okay, for the healthcare system, we have uh, heart monitoring system. Heart monitoring system is very critical, very critical. And then also, as you can see here, is railway. Railway also a very critical system. Okay, other than that, apa yang what else can we define as a safety critical system? Apa lagi yang kita boleh define? Aiman, Aiman, apa lagi yang kita boleh define safety critical system ni. Amat Aiman ada ke? Apa lagi? Contohnya kita ada space shuttle and then we have nuclear power plant nuclear power plant. This one is very critical system because any failure or malfunction can result in injury or death lah. Okay, and then formal method also can be founded as a foundation for describing a complex system lah. Okay, complex system mean that the system is very big, very big. For example, if you see the air control traffic for the airplane, it's very complex and big system because the system will trigger if something wrong with the uh, airplane. And then the third one is can be provide support for program development such as proof and model checking. This one is to detect the abnormal system behavior by using the model and abstraction method. Okay, so far do you have any question? Ada soalan ke dekat ni? Do you have any question? Tak ada, okay. Boleh. Zaito, are you okay? Are you okay, Akila? Not Akila Ismail? Okay. Okay, this one we go into more deep about the formal methods. Okay, like I said, formal methods are the system. System that we designing the system from the scratch by using several approach of methodologies that use the very rigorous mean very meticulous approach that specified using the mathematical model to build a software and also to build hardware. Both are concurrent. And then formal method use the mathematical proof as a complement to the system testing in order to ensure the correct behavior lah. Okay, then formal method also can be referred as a variety of mathematical modeling techniques that are applicable to computer system design. Okay, and then formal method also is approaches that which will support the alternative for the rigorous specification, design and verification and validation of computer system. Okay, from this statement that we can say that it also increases the trustworthiness of the system in the sense that the system that uh, could be developed is not just correct but known to be correct. Okay, formal method act as evidence. Okay, it also act as evidence. Okay, evidence to ensure the system that indeed satisfy the demand of security. Okay, satisfy. security, reliability, and correctness. Okay, can you read my apa handwritten ni boleh walaupun tak cantik kamu boleh baca Okay, this one is just an overview. Okay, next okay, formal method also are the techniques techniques in software engineering that has been used to model complex system complex system like I said is a very safety critical system. Okay, using a mathematical entities by building a mathematical rigorous model. This one by building a model by building model of complex system. It is also possible to verify uh, the system property in more through thoroughly fashion and than empirical testing. Okay, this one more on the logic than empirical testing. During the formal or system specification, an engineer or designer or developer rigorously define every step in the formal specification process using a modeling language. Later we see what is a modeling language that appropriating the formal method itself. Typically, by using a formal method, mathematical syntax and semantic that eliminate imprecision and ambiguity. Okay, what is semantic? Semantic is basically the method of structuring data in order to represent in a logical way. This one is more logical than empirical. The next formal method continuation. This one is just the continuation or the next phase. What is the phases in the uh, mathematics and formal logics? Okay, we can also assume that from the various form and level of rigorous and abstraction involve four main phases. First one is informal, second one is low, third one is medium, and fourth one is high. Lah. Okay. Okay, for the this one is basically for the modeling language. Basically, we are using mathematics approach and semantic approach. Okay, for the model, for the modeling, formal methods model is a approach of software engineering process that apply mathematical method or technique to the process of developing complex software system. Okay, it also uses formal specification language to define each characteristic of the system. Characteristic of the system is very important because we want to define and we want to avoid very costly uh, to develop the system. Okay, when you talk about the model, when you talk about the model, uh, the transformation model is the rooted in a theoretical work on formal methods. Okay, this model views software development as a sequence of steps that start from a formal mathematical specification of requirement and gradually transform it into the implementation. Okay, this one a formal methods model. We are working on the formal specification. Okay, first we are looking for the formal specification. Okay, and then we are using this one to model view software development as a sequence of steps. Okay, sequence number two is a sequence of steps. Okay, sequence of steps. And then after that, okay, number three, we are using mathematical specification. Okay, later, the last stage is we want to implement implementation. Okay, so far, do you have any question? Okay, for the implementation, we are using the software and hardware problem at the requirement, specification, and design level. Okay, is it okay, Fazirul? Fazirul boleh ke? Muhammad Fazirul? Okay, eh. Okay, and then formal method in software engineering, what to formalize? Okay, basically when you talk about the formalization, formalization in a formal method, okay, you talk about the modeling and evaluation. Okay, okay, this one, why we use formalization theory? Because of the theory is abstract representation. Theory is theory. Theory itself is the abstract representation. Okay, that express in formal deductive network. Okay, we use this one as a formal deductive framework. Okay. And then constitute a well-formed formula WFF and all the premises rule of inferences. Okay, this one will generate the WFF well-formed formula. That finally we use all the inferences. Okay, inferences. Okay. Okay, for the model requirement knowledge, so we can deduce the reason about them and specification of requirement. So we can document precisely. Lah. First, what we are looking is requirement knowledge and specification of requirements. This one is too is very common modeling requirements. Okay. And then specification of the program design, so we can verify and rectify the correctness by removing or excluding the module or the function in the design level. Okay, this one is for the formal specification uh, in software engineering. Yeah, so far, do you have any question? Ada soalan ke? kalau tak ada soalan, kita kita rehat. We rest 3 minutes. We rest 3 minutes, and after that we continue. Okay, ada yang tanya nuclear system. Yeah, nuclear system is a very life critical system. Okay, nuclear system, nuclear power plant, all of that is involving life and also safety. Okay, ada soalan lagi? Okay, kita sambung sekejap. Boleh? Can we continue? Okay, why formalize? Formalization in form method will contribute several benefit. Several benefit in order to get the benefit. What is the benefit for formalization? Uh, the first one is to remove the ambiguity and improve the precision. Also removes the flaws of the system. The flaws mean error. Okay, this one is very important. Okay, secondly, if you are looking to verify the requirement that have been met, okay, requirement here is a requirement in specification stages. Okay, and then this one is basically we are looking into the behavior of the system. Okay, either the system behave correctly or not. Okay, so they can help to disambiguate the system specification and articulate the implicit assumption. Okay, thirdly, to reason about the requirement and or design, property can be checked automatically. Okay, every stages have certain properties that we can trace and detect any flaws. And then okay, for the requirements and or design to test the consistency, explore and consequences. Okay, if the system uh, run A, then B. Okay, this one is to test the consequences. And then to animate or to execute the specification, help to visualize and validation. This one to avoid the overlooking on the critical issues and record the various assumptions and decisions. And then because we have to formalize eventually anyway, need to bridge from the informal world into formal machine domain. Okay. Because of what? Unlike the simulation, formal verification process prove the design correctness with the statistic analysis algorithm that use the equivalency checking to compare a design against a known good reference or use model checking. Okay, and we use the model checking uh, that design property and assertion are satisfied. Okay, this one we use the model checking. We use the informal to okay for this one, and then we use the model checking. Model checking. Okay. To prove uh, design design properties and assertion are satisfied. Okay, any question? Boleh ke? Okay, normally for the formalization, we are looking into the software and hardware. Okay. Okay, because of all of these, as you can see, firstly we need to do the abstraction, and then we formalize because why formalization is very important to mathematical proofs because of it is user the formal mathematical proof and then to ensure the mathematical model of the design must be aligned. Okay, and then why people don't formalize? This one is very important. Why people do not use the uh, formal method? Okay, first one, formal method tend to be lower level than other techniques because this one we need to model. We need to model uh, and we need to verify. Okay, we need to modeling and we need to verify. So from this, we can see that they include too much detail. Too much detail. This one is a rigorous process. And then formal method concentrate on consistent and correct model. Okay, it must be in a correct model. So most of the time of the developer, if the model are inconsistent, incorrect or incomplete lah. Okay, because of we need to find the consistency. For example, if we have model A and model B, model A must be consistent and model B must also be consistent in order to have the concentration. Okay, and then if the model is inconsistency, incorrect or incomplete, it is not been assigned as the complete model. This reason is the one of the reason why people don't formalize, why people don't use the formal method. Okay, people get confused about which tool are appropriate. We have several tools for formal methods. Okay, we have lots of tools of formal methods. Okay, and then some of the developers, some of the designer get confused. Okay, we have several approach or methods. Okay, okay, we have from the concept, from the requirement, and from the implementation, and we have several approach that need to have the tools. For example, we have a P model, we have a Z notation, we have a Vienna development method. Okay, we need to define to solve the software and hardware problems. Okay, and then specification of program behavior versus a modeling of requirement formal method advocates get to attach to one tool. This one is very uncommon approach. Okay, this one is very uncommon approach. Okay, and then formal method requires more effort because of costly and unfeasible. Very unfeasible because okay, it depend on the cost. Okay, depend on the cost. Okay, as we can see here, okay, I draw some of new slide. Okay. Okay, we have a formal specification method. Okay, we have formal specification method. Okay, first one we have formal specification. Yeah, secondly we have a formal proof. That takes a lot of stages. Okay, and then we got model checking, and then okay, and then lastly we have abstraction. Okay, this one from the formal specification method. Okay, for formal specification, it involves the process, translation of non-mathematical description. Okay. Okay, general purpose good for specifying the behavior of the unique key technology. For example, we have theorem proving, and then we have large Z and VDM. This one for data and modeling. Okay, for the type of specification, we have informal and formal. Okay, this one reactive modeling. Okay, for formal, this one three traditional approach. Okay, for the formal specification, we have high level. Okay, we have high level behavior. Okay, and properties of the system. Okay, and then we have a type of specification. Okay, for the type for the specification, we have informal and formal. Formal and informal name formatted. Formal and formatted. Okay. The second one is this one is first one informal. Secondly is we name it as a formal. Okay. Okay, and then this one is a new approach. This one is a traditional approach. We have a three formal specification language. Secondly, we have reactive system modeling. Formalize the dynamic model of system behavior. For example, we have a real-time embedded control system. Okay, this one we have deductive and inductive reasoning. Later on this course, you are learning about the safety, liveness, and performance. The key technology here is the abstraction to check the consistency of the uh, uh, checking process and model checking. Okay, for the applicable requirement and software that are appropriate, we have a state chart, we have RSML, we have partner stable and SCR. Okay, and then for the formal conceptual modeling, we have to capture the real world knowledge by using the model domain entities, activities, agent, assertion, and goals. This one we learn later by using the uh, set. And then use the first order predicate logic as the underlying formalism. And then the key technology, we use the inference engine, default reasoning, KBS shell, and so on. Knowledge base, knowledge base shell. Applicable requirement, this one is the key requirement of modeling. We have a rec apprentice, RML, Taylor's, Albert 2, and so on. Okay, this one I have explained. Formal, we have formal specification, formal proof, model checking, and abstraction. Okay, for the formal specification, we have high level translation, non-mathematical description. This one more on the uh, diagram, table, and natural language into formal specific language. And then it represent a concise description of high level behavior semantic. And then also in a well-defined language. Okay. Okay, this one type of formal specification. Okay, we uses the algebraic specification. Okay, and then we are using also a temporal logic model. Temporal logic model. For example, we have axiom, that statement or proposition. This one is structure of the modeling. Okay, and then okay, for the formal proof, the complete and convincing argument for validity of some property of the system description. This one or more on the complete argument, complete argument for validity. Okay, basically we are using proof, using proof to eliminate the ambiguity and subjectivity inherent when drawing informal conclusions. Okay, by using a small set of rules. Okay, this one may be done manually, but usually constructed with the automated assistant. Can be done manually, but usually constructed with the automated assistant. And then secondly, we are using model checking. Okay, model checking basically defined as more operational, more operational more operational rather than analytic. Rather than analytics. Okay, this one for model checking. Basically, we are using state mission model. State mission model that of the system is expressed in a suitable languages. Okay, suitable languages. Okay, we have two here. We have a temporal model checking and automaton model checking. And then model checker determine if the given finite state machine satisfy the requirement expressed as formula in a given logic. And then basic methods, okay, is to explore the all reachable paths in the computational tree derived from the state machine. This one is two basic uh, approaches. And then for the abstraction, simply and ignore the irrelevant detail. Okay, this one by the definition is simply and ignore irrelevant details. Okay. It more focusing on the important central properties and characteristic of the system. And then this one is to avoid, uh, okay, to avoid premature commitment. Commitment. Okay, avoid premature commitment. Basically, to design, okay, to design. Boleh baca ke saya punya tulisan ni? Boleh baca ke? Boleh baca ke? Tak dengar. Sekejap. Apa dia? Boleh. Sorry lah tulisan cakar ayam eh. Boleh lah asal kamu faham eh. Okay, okay, I have explained to you. Okay, this one mathematical model. Mathematical model. Okay, we have abstract representation of using mathematical entities and concept. Models should capture the essential main characteristic of the system while we are ignoring the irrelevant details. This one is to just to conceptualize the bigger picture of the model. And then model can be analyzed using mathematical reasoning to prove the system property or derive the new behavior of the system. Basically, we have two types of mathematical model. First one is continuous modeling, and second one we are using the discrete model. Okay, so far ada soalan? Do you have any question? Is it okay? Boleh ke? Okay, boleh saya uh, continue lah. Okay, okay, formal specification process model. Formal specification, basically you want to specify the process. What is the benefit? Benefit is to clarify the requirement at early stages. And then basically you need to have the modularization to breaking a specification into model is important organization features that will allow the reusability. Okay, and then build in model of computation to articulate the implicit assumption. It also identify undocumented or unexpected assumption. Okay, okay, and then it also expose the defect by using the maturity. This one expose the defect by exposing the maturity. Okay, maturity by documentation. Okay, and then we have under that we have a tool support. Okay, and then we have libraries. Lib- libraries. This one is uh, libraries of proven specification. Okay. And then identify the exception and evaluate the test coverage. Okay, where are formal method being applied? As I discussed, as we discussed before, although a complete formal verification of the large complex system is impractical, impractical. Um, we need to have some uh, detection of anomalies, detection of flaws that apply to various aspects or properties of the large system. Basically, when you talk about the anomalies likely, which means that we have the defect of the system uh, that that are looking into three main categories. Okay, this one is for the anomalies, logical anomalies. Okay, okay first one we have a logical inconsistency. Okay, secondly we have accuracy, and thirdly we have completeness. Okay. What is logical inconsistency? Is it a logical error to detect? This one is more on the logical error. And then for the accuracy is does the specification mean what is intent? System invariant can help in detection. This one is basically we are looking for the system invariant. Okay, and then completeness. Completeness. What is the main question? Does the specification identify all the contingency and specify the appropriate behavior for all the cases? Okay, this one is more on the contingency plan. Okay, ada soalan ke setakat ni okey ke? Boleh? Aisyah boleh? Syafiq boleh? Okay, the limit of formal methods. Okay, the limit of formal method, the system will never make 100% secure because of why? Because of we are not breaking this into axiom. We are looking more on the semantics. That means that it depend. It depend on the developer itself. Sometimes it can the error or the flaws might be happen. And then assumption about the system environment, hard to state the explicitly. The system could be deployed in environment not originally designed for convenient or lack of alternative. And then thirdly is clever intruders find out to validate this assumption. Okay, based on the assumption and abstraction. Okay, and then the last one, security is not either or properties. Pay more, gain more. Because of what? Because of several of the system protected in the way that they must be include the password. Password, certificate, biometric are measured in terms of degree of security for authentication. This one is a very critical factors. Okay. Okay, any questions so far? Okay, yeah. Okay, this one a limit of one method. They also have the benefit. A benefit from a method can be applied at various level of resource investment. It also can be integrated uh, within existing project of a process model. Formal method also can improve quality assurance. For method, this one is the limit. And then for the benefit, okay, okay, first formal method can improve quality assurance. Then formal method also can apply for various level, various level. And then formal method also can detect defect earlier. Okay. I think that's all for our lesson today.